Okay, I've made a short video about kind of fraction introduction just to make sure that your homework goes okay. So a few things we talked about in class and a few things you already know how to do, I'm sure, but I just want to kind of go back over them just to be sure. All right, I'm going to share a PowerPoint with you, I hope. We'll see if today's a good day. Look at there it is. All right, now what we're going to do is this. We're going to talk about fractions. I was going to kind of talk you through the PowerPoint a little bit. You can freeze it anywhere you want to. Take notes, and I would encourage you to do that so you'll have these in your notes, okay? Part of your homework is going to ask you to tell what fraction of the figure is shaded. Now, remember what we said last time. Your fraction, that denominator, tells you how many equally sized pieces make a whole. So remember, you've got to have equal pieces. So I look here and I have 1, 2, 3, 4, 5, 6, 7, 8 pieces that are all the same size. So that's why my denominator is 8, and I've shaded 2 of them, okay? But 2 eighths will reduce to 1/4. We'll talk about reducing in a minute. I know you already know how to do it, but I'm just going to reiterate it, okay? Now, do you see that I've got one big piece and then 1, 2, 3, 4 smaller pieces, okay? So I've got 5 pieces all together, but this is not 1/5 of the picture because the pieces are not the same size, okay? So sometimes you have to kind of delete segments in your mind, and sometimes you have to kind of add segments in your mind. So do you see that one thing I could do is this? I could kind of extend that one and come over here and extend that one and come over here and extend that one. Then I would have 1, 2, 3, 4, 5, 6, 7, 8 pieces that are alike. All right. So like on the previous one, there are 8 equally sized pieces that make up this whole rectangle, and I've got one of them shaded. So that's 1/8 of my picture, not 1/5. All right. Similarly down here, I see 1, 2, 3, 4, 5 pieces, but again, it's not going to be, you know, the same thing. It's not going to be 1 out of 5 because my 5 pieces are not equal. So what you could do again is you could go make pieces that were the same size. Okay, so I'm kind of subdividing it. All right, so let's see what we've got. If I can draw it straight, we've got 1, 2, 3, 4, 5, 6, 7, 8 right triangles that are the same. And again, I've got one shaded. So that's 1/8 of this picture. Now, one thing that's going to bother your elementary students is it confuses them when 1/8 in one picture doesn't look like 1/8 in another picture. Okay, so 1/8 of a large pizza is not going to be the same as 1/8 of a small pizza. Okay, so 1/8 means 1 out of 8 equally sized pieces. And the only way that 1/8 up here would be the same as 1/8 down here is if this hole was the same size as that hole. And you can see that these rectangles are not the same size. Okay, now look at this one. Now let me tell you what I do in my mind. What I could do is go draw a bunch of rectangles that look like these, but instead what I'm kind of doing is I'm thinking about what if I extended that and had a big rectangle, a big rectangle, a big rectangle, and then just thought of that as one big rectangle. Do you see that I would have 1/4 of that one shaded? All right, somebody else might say, well, you know what? I'm going to go draw in that, extend that. I'm going to go come over here and extend that. So they might say that they have 2/8 shaded. But we'll talk about in the next slide, next few slides, 1/4 and 2/8 are the same. Okay. Now look at this one. Do you see that this triangle is already the same size as that triangle? So I've got 1/2 shaded. 2 equally sized pieces make my whole on this one. Now, one of the things Common Core talks about is it likes fractions to be taught on the number line. Well, it's the same as doing the pictures. From 0 to 1, look what I did. There are 1, 2, 3, 4, 5, 6, 7, 8 pieces here that are the same size. So 8 is my denominator. And if I go from here to here, I've shaded in 1, 2, 3 of those. So do you understand that this point right here, this would be 3/8? because I've subdivided this 1 into 8 pieces and I've gone a distance of 3. So that's the point. This point right here would represent 3/8. Okay. So just remember, when you're trying to find out how much of a picture is shaded, you have to make sure that the pieces are the same size. And for some people, that involves like subdividing them more, like putting in some segments. For some people, it's a little bit like deleting some segments, but you just got to make sure that all the pieces are the same size. Okay, now look at this. Sometimes in the book, they're going to tell you to write equivalent fractions. They're going to say, write 3 fractions that are equal to 3/4, or equal to 1.5, or equal to 5/6. Well, what we're going to do is we're going to use the identity property of multiplication. Remember what it says. You can multiply any number by 1 and the number stays the same. So 2 times 1 stays 2. -4 times 1 stays -4. And 1/3 times 1 stays a 1/3. So it works with any real number. Well, you know, there are a lot of ways you can write 1. So what I'm going to do is I'm going to take this 3/4 and I'm going to multiply a lot of different forms of 1. Now remember, 1 basically can be any number. All right, let's see what's happening up here. It's having a hard time. All right, let's try it again. Let's see if I can get back to my thing. I can multiply by any form of 1 that I want to. I just decided to choose 2 divided by 2. Well, 3 times 2 is 6, and 4 times 2 is 8. So I know that 3/4 has the same value as 6/8 because all I really did was multiply 3/4 by 1. Okay? So does everybody understand that this 2/2 is the same thing as a 1? And by this identity property of multiplication, I know that 3/4 times 1 has to be 3/4. Same thing, instead of using 2/2, I could have used any number over itself except 0/0. So I just arbitrarily picked 5/5. Well, 3 times 5 is 15, and 4 times 5 is 20. So 15/20 has exactly the same value as 3/4, because really I just said 3/4 times 1. Again, any number divided by itself. So this time I decided to use 10/10. And 3 times 10 is 30, and 4 times 10 is 40. So 30/40 is the same thing as 3/4. So if you're told to write equivalent fractions, you can take a fraction multiplied by any form of 1 that you want to. You could use a -17 over a -17. You just can't use 0, of course, over 0. But anything else times itself is going to give you an equivalent fraction. All right. Let's go to the next slide. Okay. Now, what if they tell you to simplify the fractions? Okay. So if they tell me to simplify the fractions, then they remind you here that a fraction simplified, first of all, when it's proper. Now remember what proper means. Proper means the numerator needs to be smaller than the denominator. Okay, let's clear those drawings from before. All right. And the only common factor that the numerator and denominator can have is 1. All right. So I ask you, which of these fractions are in simplest form? What's the only common factor between 2 and 7? Isn't it 1? And isn't my numerator smaller than my denominator? Okay, so 2/7 is in simplest form. Now, 8/3 is not in simplest form. Do you know why? I mean, the only common factor they have is 1, but this is an improper fraction. For it to be in simplest form, that numerator is supposed to be smaller than that denominator, and my numerator is bigger than my denominator. Okay? All right, so this one's not in simplest form. Now, here the numerator is smaller than the denominator. This one is proper, but again, it's not in simplest form. Why? Do you understand that 2 will go into 10 and 2 will go into 24? So they have a common factor of 2. And the only common factor they can have in simplest form is 1. All right. So that one's not in simplest form. And this one's not in simplest form. Okay. What about this one? Ooh, it's got a bunch of problems. First of all, the numerator is bigger than the denominator, so that's not good. And 10 is a common factor. So that's not in simplest form. What about 11/18? Well, the only common factor they have is 1, and the numerator is smaller than the denominator, so that one's in simplest form. Now, if you're not careful, you might think this one is in simplest form because the top number is smaller than the bottom number. But remember, what is our shortcut for 3? 3 is a factor of 18. Remember, when we add the numbers up, if that sum's divisible by 3, this number's divisible by 3. And 9 will divide by 3, and 12 will divide by 3. So 3 is a common factor of both, so that doesn't work. All right, and this one is not proper. It's improper because the top number is bigger. So make sure that you can tell when a fraction is in simplest form. The numerator's got to be smaller than the denominator, and they cannot share any factor except 1. All right, so what if they're not in simplest form? I say simplify. Well, one way is to divide by the greatest common factor. So we learned to do that in the last chapter. So the greatest common factor that 10 and 24 have is 2. So what you're really doing is you're dividing by 1. So any number divided by 1 stays the same. It's just I'm using the form of 1 as 2 divided by 2. So 10 divided by 2 is 5, and 24 divided by 2 is 12. The top number is smaller than the bottom number, so this is in simplest form. So the only factor 5 and 12 have in common is 1, and the numerator is smaller than the denominator. So that's how I know that this one's in simplest form. All right, look at this one. 24 divided by 36. So I could use my prime factorization method. I could use Euclidean. I could use intersection of sets and find that the greatest common factor that they have is 12. So that's why I decided to write my 1 as 12 divided by 12. Then 24 divided by 12 is 2, and 36 divided by 12 is 3. So the only common factor they have is 1, and my numerator is smaller than my denominator, so I know I'm in simplest form. Now, what if you don't use the greatest common factor? Well, if you don't use the greatest common factor, you're going to have to do it more than once. Like 4 is a common factor, but it's not the biggest one. So look what happens if I choose 4 divided by 4. Well, 24 divided by 4 is 6, and 36 divided by 4 is 9. But see, that's not in simplest form because they have a common factor of 3. So I've got to do it again. So I divide by 1, but it's the form of 3 divided by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 3. So I end up getting the same answer. It's just if you use the greatest common factor, you've only got to divide 1 time. If you pick a common factor but not the greatest one, you're going to have to divide a bunch of times. Now, some of us have a hard time getting the greatest common factor. So this is a way that I would suggest to you that's easy. It's not the quickest, but it's probably the simplest. All right. Use your prime factorization. It's really using the prime factorization method in a kind of a different way. Do a factor tree for your numerator and write it down, and do a factor tree for your denominator and write it down. Like here's my factor tree for 24, 4 times 6. So it's 2 times 2 times 2 times 3. All right, 36, I use 6 times 6, and then my 6 is broken down into 2 times 3. So look what happens. This 2 will divide out with a 2 down here. I can divide this 2 out with a 2 down here. And then I can divide a 3 out with a 3 down here. So look what's left. 2 thirds is simplified. So it's really quick. Remember, when you're dividing, what you're really doing is you're saying that's a 1. 2 divided by 2 is a 1. 2 divided by 2 is another 1. And 3 divided by 3 is another 1. And 1 times 1 times 2 times 1 is 2. And 1 times 1 times 3 times 1 is 3. So that's the way you're probably going to see me doing the simplification because it's very easy. So let's look at a few more just to make sure we're good. Okay. All right. Let me come up here, see if I can get it to cooperate. All right. Whoop, 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 whoop. Try and come back, come back. Okay. Let's see if it's going to let me do it. All right. Some days, there we go. All right, I'm going to clear all these drawings. All right, so look what we've got. I did 30 divided by 24. Now, where did I get 2 times 3 times 5? I did a factor tree on Scratchwork. So if you do a factor tree for 30, you should get 2 times 3 times 5. If you do a factor tree for 24, you should get 2 times 2 times 2 times 3. So you can freeze the video and do a factor tree and check and make sure that I'm right. Okay. And then I divide them out. 2 divided by 2, that ends up being a 1. Okay. I did 3 divided by 3, and that ended up being a 1. So 1 times 1 times 5 is 5. And 1 times 2 times 2 times 1 gives me 4. Now, why isn't 5/4 the answer? Because remember, the numerator needs to be smaller than the denominator, or it's improper. And we talked about in class, if it's improper, it takes 4 equally sized pieces to make a whole. And see, I've got 5 pieces, so I've got more than a whole. So how many 4s can I pull out of 5? 1, and I've got 1 piece left over. So remember, the number on top is my whole number, and then I put my remainder pieces over my divisor. So 1 and 1/4. So the numerator goes inside as the dividend. I did a factor tree for 36. I did a factor tree for 10. And I can divide out those 2's, and that gives me a 1. And then I've got 1 times 2 is 2, times 3 is 6, and 6 times 3 is 18, and 1 times 5 is 5. So the only common factor they have is 1. So that part's fixed, but it's top heavy. I need my numerator to be smaller than my denominator. So if it takes 5 equally sized pieces to make a whole, do you see I have a bunch more than a whole? How many 5s can I pull out of 18? 3. So I've got 3 whole pieces right there. And then this remainder becomes my numerator. I put my number of pieces over my how many equally sized pieces make a whole. So I have 3 whole pieces, 3 wholes with 3 pieces left over. All right. Now, sometimes you're not sure if they're simplified. Well, see, when you do a factor tree for 9, 2's already prime, nothing's going to divide out. So that tells me that 9/2 was already simplified as far as only common factor is 1. But because that numerator is bigger than that denominator, I've got to take 9 and divide by 2. How many 2's can you pull out of 9? 4. So remember, the number on top, that's your whole number part. Okay. And then remainder goes over divisor. So remember, that's 4 plus 1/2. 4 whole ones plus half of another whole one. What about 48 over 60? Well, if you do a factor tree for 48, you should get that. If you do a factor tree for 60, you should get that. So freeze it and try that. Okay, now that you're back, do you see that 2 divided by 2? So that goes out and gives me a 1. This 2 divided by 2 went out and gave me a 1. And that 3 divided by 3 went out and gave me a 1. And so 2 times 2 times these 1's would be 4. And then a bunch of 1's times 5 is 5. And the numerator is already smaller than the denominator, so there's no dividing to do. I only divide when the numerator is the same or bigger than that denominator. So that's how I'm going to simplify fractions into lowest terms. Okay. All right. Look at this real quick. All right. What if you have to compare fractions? Like, how do you know which one is bigger? Well, there are different ways of doing it, but I think the easiest way is just to change them to what are called like fractions. Now, like fractions is a way of saying that they have the same denominator. See how these denominators are different? They're going to be called unlike. So how do you find like fractions? Well, this goes to least common multiple. All right. You find the least common multiple of 3 and 4 using the way we did last time in the last chapter. And the smallest number that 3 and 4 will both go into is 12. So I'm going to change 2/3 to something over 12. So when I first did it, here's what it looked like. I would have like 2/3. All right, equals. Maybe if I can get my pen to cooperate, and I would have something over 12. Now, how do I know what number went up here? Well, here's what I did in my head. I said, okay, what do you multiply 3 by to get 12? 4. So I must have multiplied this bottom by 4. Well, if you multiply the bottom by 4, you've got to multiply the top by 4. Now, remember why that's true. Because really what you're doing is you're multiplying 2/3 by the number 1, okay? And then 2 times 4 was 8. So that's how I knew to put 8/12. And the same thing here. I said 4 times what gives me 12, and it was 3. So if you multiply the denominator by 3, you got to multiply the numerator by 3, and 3 times 3 is 9. So 2/3 is the same thing as 8/12, and 3/4 is the same thing as 9/12. Well, when the denominators match, all you've got to do, because the pieces are the same size, all you got to compare is your number of pieces, and 8 is smaller than 12. So when the denominators match, all you got to compare is the numerators. So 2/3 is less than 3/4. Well, what about 7/10 and 10/15? Again, I had to find the least common multiple between 10 and 15 using prime factorization or intersection of sets, and it was 30. So I'm going to change both of these fractions to have 30 on the bottom as a denominator. Well, what do you multiply 10 by to get 30? 3. So if you multiply the denominator by 3, you got to multiply the numerator by 3. And 7 times 3 is 21. So 7/10 is the same thing as 21 over 30. Well, what's 10/15? What number goes over 30 to be the same there? What do you multiply 15 by to get 30? You multiply 15 by 2. So if you multiply the bottom by 2, you got to multiply the top by 2. And 10 times 2 is 20. So 7/10 is the same thing as 21/30, and 10/15 is the same thing as 20/30. And 21 is bigger than 20, so 7/10 is bigger than 10/15. Well, what about 5, 6, and 15/18? Well, their least common multiple is 18. What do you multiply 6 by to get 18? 3. Then you've got to multiply this numerator by 3, and 5 times 3 is 15. Well, see, if the bottom doesn't change, the top isn't going to change. So look, actually, these are exactly the same. They're both the same as 15/18. This is just a simplified form. So if you've got to compare fractions, or sometimes they'll give you a list of fractions and tell you to put them in order. The easiest way to do that is to change them all to like fractions. That means to get them all to have the same denominator. Then all you've got to worry about is the numerator. You can put them in order. Okay? So your homework hopefully will be much better. So you got this video to go back and keep looking at anytime you want to. Freeze it and take some notes. And let me know if you have any questions.